While molarity is the most common concentration unit we use in chemistry, we can have additional concentration units that are used. We're not going to cover all of the possibilities here, but just a couple of ones that show up in a lot of environmental aspects. Particularly, these are concentration units that are used for things that are not present in large concentrations, that are what we call trace solutes. And so one is just to use molarity, but to express it in terms, to use the SI prefixes. So we can do things like millimolar, like this. This would be called millimolar. And this is the idea of molarity, but now it's times 10 to the minus 3, right? So it's a 10 to the minus 3 moles per liter. So you're adding that factor of just like you would like a milligram or something like that. And you can even go smaller than that. You can have micromolar, which is with the mu symbol, the Greek letter mu, whereas this is 10 to the minus 6 moles per liter. And then you can even go down to like nanomolar. So this is micromolar, and this is nanomolar. And these are all just based on the SI prefixes that we learned at the beginning of the class. This would be 10 to the minus 9 moles per liter. So these would be one way to express concentrations that are very small. It's still the same idea as molarity. You're expressing it in terms of moles per liter, and I should specify that all these are for liter of solution, because there are different concentration units where it's, say, liters of solvent or something like that. But we are only going to worry about ones that are in terms of solution. So this is still thinking about a number of moles per unit volume of solution. One additional, or a couple of additional concentration units that show up are expressed instead of using moles, they're expressed as mass concentrations, meaning that we're expressing them in terms of grams or kilograms or things like that. So instead of using moles, we're instead comparing things directly mass to mass. So these are mass concentrations or mass to mass ratios. So this is something where we express something in terms of a mass of our solute over a mass of solution. So two of these that are really common are one that's called ppm, or parts per million. And this is equivalent to 1 microgram of solute for every 1 gram of solution. And so this comes from parts per million, just means that essentially if you divided your solution up into a million pieces, 1 part of that would be your solvent. So that's where this name comes from, parts per million. So if I had 1 gram of solution, a millionth of that is 1 microgram. And that's where you get this. You can convert this into different masses. There's in your textbook goes through this. This is, you can show that this is also equivalent to 1 milligram of solute per 1 kilogram of solution. And you get this by just converting micrograms to milligrams for the solute and grams to kilograms for the solution, and show that these are equal to each other. A related unit that's an even smaller concentration is the part per billion unit, parts per billion, ppb, which is the same idea. It's a mass to mass ratio, 1 ppb, but now we're looking at, instead of thinking of our solution as broken up into a million pieces, we break it up into a billion pieces, and 1 part per billion is, you have one of those parts, one of those billions, one of that billion is your solute, and the rest is also your solvent. So we would express this as 1 nanogram of solute per every 1 gram of solution. Or equivalently, we can convert this one as well, and we would get 1 microgram of solute per every 1 kilogram of solution. So these will show up every once in a while. We're not going to use these a lot. We will much more commonly use molarity, but it is good to be familiar with these units, and they do show up quite a bit in everyday life as well. Everyday life. If you're interested in particularly environmental, and I know that there are quite a few people who take chemistry that are interested in environmental chemistry, and we think about pollutants often in terms of these units of parts per million or parts per billion. They have a big effect, but there's not tons of them, hopefully, present in the things that we're measuring. So you might see these if you're looking at pollution in like groundwater or in the ocean or in the air, and these units show up quite a bit there. So just want to introduce them. They're going to show up every once in a while, and it's good to know that how they're defined, that they're defined in terms of masses instead of moles. And so with these, you don't need to use a molar mass to convert from a measured amount to moles, which is one nice thing about them. So that concludes our talk about concentration units, and in the next video, we're going to be looking at how do we make dilutions of concentrated solutions, and how do we calculate the values of the diluted samples.